Probing the atmosphere. Much of what is known about the composition and properties of the atmosphere is derived from direct sampling and measurement. Through the years, exploration of the atmosphere has progressed from tentative probing with primitive instruments to sophisticated remote sensing that employs space-age technology. At first, scientists investigated the atmosphere from the ground, climbing rugged mountain peaks to sample the rarefied air. In 1743, the intrepid Benjamin Franklin conducted his famous kite-flying experiment to investigate the electrical properties of the atmosphere. Franklin attached a brass key to his kite string in order to attract an electrical current during a rainstorm. Fortunately, a lightning bolt was not attracted to the key, for it surely would have been lethal. From then until the 1930s, kites equipped with thermometers were used to compile temperature profiles of the lower atmosphere. In 1804, the French scientist J.L. Gay-Lussac ushered in the age of manned balloon exploration of the atmosphere. He took air samples and measured temperature and humidity. On one ascent, he reached an altitude of 7 kilometers 43 meters. By the close of the 19th century, invention of recording instruments made possible unmanned balloon monitoring of the atmosphere. As a balloon ascended, its instrument package profiled temperature, pressure, and humidity. Eventually, the balloon burst, and the instrument package parachuted back to Earth where the recordings were read. Through the early part of the 20th century, weather instruments borne by balloons, kites, and aircraft provided information on the lowest 5 kilometers or 3 meters of the atmosphere. A leap forward in atmospheric monitoring came in the 1930s when the first radiosonde, a small instrument package equipped with a radio transmitter, was carried aloft by a helium-filled balloon. These devices transmit to a ground station continuous altitude measurements, called soundings, of temperature, pressure, and relative humidity. With radiosondes, the data are received immediately. No recovery of a recording instrument is needed. Today, radiosondes are sent up simultaneously at 12-hour intervals from hundreds of ground stations around the world, Figure 11. Information is monitored up to the altitude at which the balloon bursts, typically about 30 kilometers or 19 meters, and then the instrument package descends to the surface on a parachute. Some radiosondes are recovered, refurbished, and reused. Radiosonde movements usually are tracked from the ground by radar, thus giving an indication of variations in wind direction and speed with altitude. A radiosonde observation of this kind is called a radiosonde. Direct exploration of the middle and upper atmosphere was greatly aided after World War II by the development of rocketry, and later by the introduction of satellites. Until the first rockets penetrated altitudes above 30 kilometers 19 meters, our understanding of the upper reaches of the atmosphere was based on speculation and indirect, albeit ingenious, ground-based studies. The age of satellites and remote sensing began in 1957 when the Soviet Union launched Sputnik 1. These eyes in the sky are invaluable tools for weather observation. They provide data on cloud patterns, winds, temperature, humidity, and radiation. The United States orbited its first experimental weather satellite, TIROS, television and infrared observational satellite, in 1960. Since then, the United States has launched a series of increasingly sophisticated weather satellites,